Okay, welcome to video 5 of the Psychometrics Refresher lecture, and the last one in which we go over the main themes of the course. Um, like I said, there might be one or two more depending whether there's a bunch of questions that keep popping up out of the Refresher tutor groups. I might make some additional quick answer videos for that, but this is the last one where we go over the main themes. And what we're going to look at here is we're going to look at real life decision making, basically. So if you look at reliability, validity, and dimensionality, and biases that might come into tests. But now, when all of that is taken care of and we check for all that, oftentimes we're going to use the test to make decisions in real life, right? So we're going to make decisions about whether people, when they're doing job interviews, whether they are likely to be successful. So we might do it that way. We're going to see whether course exams, for example, can predict which students are going to be successful in their thesis. It could be that we're doing tests to see whether people should be admitted to certain programs, yes or no. But usually, we're going to use tests to make decisions. Now, when we're making decisions, we usually dichotomize, right? So we're usually not going to say, okay, this person is more likely to be successful, or this person has a probability that's like 5 points larger to be successful than somebody else. We're usually making black and white decisions. We're usually going to say, okay, this person is successful or not, or person is going to pass a certain course or not. So when we're doing real life decision making, we're usually working with dichotomies. And there are two dichotomies that are important when doing these real life decision making. But we have two ingredients, two scores that go into this decision making process. The first thing, obviously, is the score on our test, right? So we're going to make decisions based on the test. And in this example, I'm going to make decisions about whether a person is going to pass their bachelor thesis, yes or no, based on the information I have about people on their exam for course 2.2. So the test I'm going to use to make decisions is the course exam for course 2.2. And I'm going to predict whether people are successful on this bachelor thesis. Now we have two different names for the course exam and the bachelor thesis here. The thing that I'm going to predict, so that I'm going to use to make predictions, so my test is just called the test. The thing about which I'm going to make predictions, so in this case, whether a person will be successful in the bachelor thesis, this bachelor thesis is usually called the criterion. So the thing I want to predict is the criterion. So if I want to predict whether you're going to pass your bachelor thesis is the criterion. If I want to predict whether you're going to be successful in a certain job success is the criterion. So we have the test and we have the criterion. And we're going to do dichotomies on both the test and the criterion. We're going to check whether somebody passed the test or not. And we're going to check whether somebody passes the criterion or not. And that means that we're going to divide the total number of possibilities in 4 distinct quadrants. Why 4? Well, like I said, you can pass the test or not. So everybody that scores to the right of this vertical blue line passed the test, got a score 5.5 or larger. So all people over here passed the test. All people over here did not pass the test. Similarly, everybody above the horizontal blue line passed the criterion. So got a 5.5 or larger for the bachelor thesis. So all these people passed the thesis. All these people down here did not pass the thesis. Right? So we have 4 groups in total. We have did not pass the test, passed the thesis. So this could be considered unexpected. You didn't pass the test, so we would guess that you also wouldn't pass the thesis, but you did. We have passed the test, passed the thesis. This is what we would expect. You passed the test, so we would predict that you would pass the criterion as well, and you did. We have passed the test, did not pass the criterion, down here, bottom right. Also not what we would expect. You passed the test, so we would guess that you would pass the criterion as well, but you didn't. And lower left, did not pass the test, did not pass the criterion. Again, as you would expect, you didn't pass the test, so we would predict that you also would not pass the criterion, and you didn't. So we have 4 distinct quadrants here. Alright, now to give them some catchier names. Catchier then, you did not pass the test and you did not pass the criterion as expected, which is a little bit long. We're gonna name these 4 quadrants. Quadrant A, incorrectly rejected, because the test said you wouldn't be able to do it, but you did. So A, incorrectly rejected. B, correctly accepted. The test said you could do it because you got a passing grade on the test, and you could because you got a passing grade on the criterion as well, so correctly accepted. C, correctly rejected. The test said you wouldn't be able to do it because you didn't get a passing grade, and you didn't get a passing grade on the criterion as well, so correctly rejected. And D, incorrectly accepted. The test said you would be able to pass the criterion, but you didn't. And as you can see, A and D represent basically wrong decisions by the test, and C and B correct decisions by the test. So the larger the percentage of people in C and B, the happier we are. Okay, now there are some informative rates that we can look at in these quadrants, or with these quadrants. The first thing we can look at is the base rate. And the base rate is basically saying, okay, forget everything else, just look at the criterion and nothing else. So in this case, just look at the bachelor thesis, ignore the course exam for now. Just looking at the bachelor thesis, how many people pass the bachelor thesis? So without information on the test whatsoever, just out of all the students, how many pass the bachelor thesis? Which in this case would be the number of people in area A and area B divided by everyone. So A plus B divided by A plus B plus C plus D, which is 10 plus 28 divided by everybody, so 10, 28, 17, 45. So we have a base rate of 0.38, which tells us that 38% of the students pass their bachelor thesis. The second informative rate that we often look at is the test rate. And the test rate is basically saying, okay, forget the criterion, just look at the test. Out of all the students, what proportion passes the test? So we're going to look at areas B and D, because these are all the students to pass the test. They got a score of 5.5 or higher. So ignoring the criterion, just looking at the test. Out of all the students, what proportion passes the test? Well, that's B plus D divided by everyone. So B plus D divided by A plus B plus C plus D. Another informative rate is the success rate, so the proportion of correctly accepted students. Well, what is the proportion of correctly accepted students? Well, okay, we know that the accepted students are in B and D, right? Because those are the students that pass the test. But out of the students in area B and D, which ones are correctly accepted? Well, only the students in B, right? Because only the students in B passed both the test and the criterion. The people in B passed the test, but they couldn't pass the bachelor thesis, so they were accepted by the test, but the test made a wrong decision. They were accepted, but they shouldn't have been. So we're going to look for the success rate out of all the accepted students, so not all students, only the accepted students. Out of all the accepted students, what proportion was accepted correctly? So that's only B. So the success rate, you can calculate that by doing B divided by B plus D. In this case, 38%. Okay, now the success rate is often what we're interested in, right? So we're interested in, okay, how many people that are accepted by the test are correctly accepted. And it is important to realize that out of those informative rates, so we also look at the base rate and the test rate, it's important to realize that the base rate and the test rate influence the success rate. So they're not completely independent rates. The success rate, what we're often after, is influenced by both the base rate and the test rate. I'm going to see how that works. Now, why is the success rate dependent on the test rate? Well, remember, the success rate is the number of people in B divided by B plus D, right? So the number of observations in quadrant B and quadrant D together decide the success rate. Now, as you can already see a little bit from this figure, the number of people that are in B and in D, so in quadrant B and quadrant D, depends on the location of this vertical line, right? And what was this vertical line again? This vertical line was the cutoff that we used for saying whether a person passed the test or not. And where we place this vertical line depends how many people pass the test. So the location of this vertical line determines the test rate, how many people pass the test. If I move it all the way to the left over here, everybody passes the test, so I have a test rate of 100%. And if I move it all the way to the right over here, nobody passes it, so I have a test rate of 0%. So the location of this vertical line determines the test rate, but it also determines the number of people in B and D. So here you can see that this test rate influences the success rate, right? So if these are my cutoff locations for the test and the criterion, then in this specific example, I have a success rate of 60%. Out of the 5 people that pass my test, 3 are accepted correctly, so 3 out of 5 is 60%. If I move my test cutoff a little bit, so I change my test rate, now all of a sudden only 3 people pass my test, and out of those 3, 2 were accepted correctly. So now I have a success rate of 2 divided by 3, or 0.67, so 67%. So my success rate increased by 7% because I changed my test rate. Alright, now I'm going to skip this. It basically says if there's no relationship between the test and the criterion whatsoever, so the two are not related, the test doesn't contain any interesting information about the criterion, then it doesn't matter, then there's no relationship between test rate and success rate. But I'm going to skip that for now, because what I want to show you is some less extreme example. So here we're going to look at correlation of 0, but that's a little bit unrealistic, so let's look at some more realistic situations. Okay, now I already showed you that the test rate, so the position of the vertical line, influences the success rate, right? And obviously we can say something similar for the base rate, so the position of the horizontal line. The position of the horizontal line also influences the proportion of people in quadrant B and quadrant D, so the base rate also influences the success rate. Now what might be less clear is that the correlation between the test and the criterion also influences the success rate. Now how do we see the correlation in this figure? Now think back to course 2.2. When we were looking at correlations, we said that a way to visualize the data then will be using scatter plots, right? And we said that there's a couple of things that we could see in those scatter plots. We could see the sign of the correlation, whether it was positive or negative. We could sort of see the shape of the relationship, because we were assuming that correlations are always looking at linear relationships, so we were looking for anything non-linear, like quadratic things. We didn't want to see that either. And we could see the strength of the correlation, and we could see that in the width of the scatter plot, right? So the narrower the point cloud, the more everything was on one straight line, the stronger the correlation was. So the correlation shows up in this figure in the size of this ellipsis. The narrower the ellipsis, the more it's squeezed together in one diagonal line, the stronger the correlation is. Alright, now, what does that correlation represent here? Well, the correlation represents the relationship between our test and an external measure, an external criterion that it should be related to. Now think back to the video on validity. When we were talking about construct validity, we checked the relationship with other measures, right? So that's basically what we're doing here. We're checking the relationship between our test and another measure. So this is a measure of validity, and we're trying to predict passing something in the future. So this would be a measure of predictive validity. So correlation here is a validity coefficient. Alright, now how does this validity coefficient, so how does this correlation between our test and our criterion influence the success rate? Well, let's see what happens when the correlation between the two changes. Let's see what happens when the validity coefficient changes. We're going to start with the initial situation again. So here, 5 people passed my test, 3 were accepted by my test correctly, so my success rate is 3 divided by 5, 60%. Okay, now, let's see what happens if the correlation between test and criterion goes up. So the ellipsis, as you can see, becomes narrower, right? It gets squeezed together a little bit, it gets squeezed more towards the diagonal line, so it gets narrow. If that's the only thing that we change, so if the relationship between our test and the criterion becomes stronger, then without changing anything, 5 people still pass my test. But out of these 5 people, purely due to the fact that the test is now a better representation of the criterion, the validity coefficient is higher, out of these 5 people, 4 people now also pass the criterion, instead of the 3 that we had earlier. So, with this increased correlation between the two, with this increased validity coefficient, the success rate goes up from 0.6 to 0.8. Instead of doing 3 divided by 5, we now have 4 people that were correctly accepted. So we do 4 divided by 5, or 80%. So because we have a higher validity coefficient, we have a higher success rate. So here is another example of why you want to have a high validity, not just to make sure that you're measuring what you want to be measuring, which is of course hugely important, but the higher the validity, the better your decision making based on the test is going to be. Alright, now I already mentioned the base rate, that it was working in the same way as the test rate to increase your success rate, but I'll show you the picture as well, just to make it a little bit clearer. Remember that the base rate basically just states, forget about everything else, just look at the criterion, how many people pass the criterion, so it's basically the location of this horizontal dashed line. Well, let's see what happens when we change the base rate. Here, 5 people, because this is the original example again, 5 people again pass my test, right? 5 people scored to the right of this vertical line. Now, how many of these people are correctly accepted by the test? 2. So 2 out of 5, 40%. Now what happens when I change the base rate a bit? And changing the base rate, I could do that by either moving this dashed line down or moving the entire point cloud up. It's all about the relative position of the horizontal line relative to the ellipsis. I'm going to talk about it a little bit more, but it has to do with this horizontal positioning. Here you can see that if we change the base rate, the proportion of people in B and D changes, and so does the success rate. So now, by changing the base rate, by making passing the criterion more common, the success rate changes from 40% to 68%. So here you see that the rarity of an event on the criterion influences your success rate. If something is more common, it's easier to predict accurately. Now, why didn't I just move this horizontal line? Because that would be easier, right? We moved the vertical line where we're looking at the effect of the test rate. Why didn't I just move this horizontal line to change the base rate? Well, I could do that, and I already discussed what that would do, but let's be honest, in practice that would be a little bit weird, right? It would be saying, okay, I want to predict whether somebody is successful on the bachelor thesis. My success rate isn't high enough. You know what? Instead of making people get a 5.5 to pass the bachelor thesis, I'm going to say as long as they get a 3, it's already good enough. That would definitely change the base rate, definitely change the success rate, so it's in theory possible, but it's not something that you would do in practice, obviously. So a more realistic example of an increased base rate is looking at something that's more common. The thing is, the higher the base rate, so the more common something is, so the more common it is to pass the bachelor thesis, in this case, in this example, the easier it is usually to predict that correctly. Alright, that was it for the 5th and final refresher video. I hope you guys find this useful, and good luck with your final preparations.